Okay, 4.6, part 2, arithmetic sequences. We now can identify, we can write the next three terms in an arithmetic sequence. We can identify them from a graph. Now we are going to write the equations for an arithmetic sequence. It might become useful, and how equations are super useful. Here, in this example 1, I was given the first 4 terms. I was able to write the next 3 terms. But what if I wanted to know what was a sub 20? Again, reminder from this previous section, what this means is I'm looking for the 20th term in this sequence. Well, based on the information I have, I would have to just keep writing out all the way till I get to the I'd have to write all the way out until I get to the 20th term. Okay, which is possible if 20th term isn't too bad. But what if I wanted to get to the 150th term? A sub 150. I don't want to write out that many terms. This is where an equation is useful. Okay, your textbook has you memorize some different equation to come up with a different formula to come up with the equations for these. I have found it useful to the less things you have to memorize, the better. And an arithmetic sequence is linear. So we're going to use our linear methods. What I mean by that, we have y minus y1, x minus x1, to come up with a linear equation. We're going to use this then to write an arithmetic sequence because it has that common difference. And the m here is that common difference, how much it goes up each time. The m is your common difference. Okay, so here, first things first is to come up with your ordered pairs. So we want to write an equation for the nth term of this arithmetic sequence. So they give us the sequence, again remembering this is the first term, this is the second term, this is the third, this is the fourth. So my x's are the term number. The y's is the actual term value. So I have the point 114, 211, 38, 45. Okay. And so then I can come up with that common difference. Well, that difference is the slope. And slope comes in change in y over change in x. Okay. Well, my change in y to go from 14 to 11, that's going down 3 each time. Down 3, down 3. But my change in x is going up by 1 each time. So my slope is -3 in this case. And then I can just use one of these random points to put in. I'm going to use the point 114. So I'm going to write the equation down first. Y minus y1 equals m, x minus x1. So y minus 14 equals -3x minus 1. And then now I'm going to have to distribute this -3 in. Okay, so y minus 14, -3x plus 3, add the 14 to both sides. Y equals -3x plus 17. Okay. Now the only thing we change now at this point is how we write this. Since this is going to be an arithmetic sequence, since we're dealing with an arithmetic sequence, instead of an x, it's going to be an n. Okay, and this is my a sub n, the term. So my y becomes an a sub n, and my x becomes an n, because we're dealing with sequences. So a sub n equals -3n plus 17. So what this equation now gives me is if I want to find like the 10th term, all I have to do is put a 10 in for n, take -3 times 10, add the 17, and that'll get me what the 10th term out here would be if I wanted to know what a sub 10 was. Okay. So we found an equation for the nth term of the arithmetic sequence. All right, so it looks like we have one more example here, example 5. I'm sorry, hit the mic. Online bidding for a purse increases by 5 for each bid, typo, after the initial $60 bid. Okay, so I'm going to write out my terms here. So the first bid is $60. So my first bid is $60. So this is the bid number, and this is the dollars. So then the second bid would be, it goes up by 5 each time. So the second bid would be 65. The third bid would be 70. The fourth bid would have to be 75, so forth and so on. So here we have an arithmetic sequence where my difference, my common difference here is 5. Okay, so that corresponds, it goes up by 5 each time. This goes up by 1 each time. So that would be my slope. My slope is my rise up by 5, my run of 1. So my slope is 5. So write a function that represents the arithmetic sequence. So y minus y1 equals mx minus x1. Y minus, let's see, should we use this first point, 160? Y minus 60, slope of 5, x minus 1. So distribute that 5 in. 5x minus 5, let's add the 60 to both sides. So y is equal to 5x plus 55. Okay, now I just need to write it in sequence form. So my x's become n's, my y becomes a sub n. So a sub n equals 5n plus 55. So there's my function that represents the arithmetic sequence. Graph it. So I'm just going to come in and I'm going to graph these points. We are all positive, so I only need quadrant 1. Okay, to spread this out a little bit, I'm going to go over 2 each time. 3, 4, keeps going there. And over here, I think I'm going to count by 5, 10, 15, 20, 45, there would be 50, 55, 60, 65, 70, 75, 80, 85, just to kind of get some points. We're counting by 5s each time, so I want to mark that. Whenever you're counting by something other than 1s, you need to mark that on your graph. So the first bid is $60. So first bid is up here at 55.60. Second bid is at 65. Third bid would be 70. Oh, let's get rid of that, sorry. Fourth bid is 75. Fifth bid, sixth bid. Okay, so it's going to continue doing that. I do not connect the dots. Graphing the function is just the dots. The winning bid is 105. How many bids were there? So I could keep extending this out. I could go, okay, the next one was 80, then 85, and count them up. Or I can be like, hey, the winning bid was this number here. Oh, this number was my output. My winning bid was 105. And I now have a function rule. I'm trying to find what numbered term was it. So I now I have an equation I can solve. I can subtract the 55 from both sides. Okay, 105 minus 55 is 50. Divide both sides by 5. N equals 10. So this tells me it was the 10th term. So it was the 10th bid. There were 10 bids. Okay, last bit of practice, page 214. I want you to do 32 through 42 even, number 50, number 54, and then 58 through 64.